All right, so we're going to be talking about complex numbers. And when we're talking about complex numbers, it's important to realize that whether a number is complex or real is a lot like being positive or negative. So if I were to go back in time, if I were to go back, say 200 years in time, you would find some some mathematicians who didn't believe in negative numbers. They would say, "Ah, look, I have 3 pens. Show me negative 3 pens." Ha 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 ha! Checkmate. And it's funny because we now have some great analogs for what a negative number is. I can think of a negative number as something just less than zero, and that's a wonderful thing. So I could have something that's, I could have, say, like, set sea level is zero, and anything above sea level, that's my elevation, that's my positive. If I've got below that, this is negative. And this is just conceptual of what's the difference between positive and negative. We have some ideas about that. I could think of above freezing or below freezing. Again, it's all centered on that zero. There's and whenever we talk about negative numbers, we can't get away from debt. Your banks definitely believe in negative numbers. I wish they didn't sometimes, but they definitely do. But when I'm dealing with a complex number is a little bit different. If I the short definition of what a complex the one of the things that I could think about for a complex number is, well, I could say if I were to take the square root of any positive number, this is going to be real. Or I could even say either the positive or negative root of any positive number would be real. But if I take either the positive or negative version of a negative number, this is going to be complex. And when I'm thinking about this, there's a lot of, I'm just giving you some broad strokes as to what makes something either real or complex. Another way of thinking about this is, oh, here I've got my number line. We're used to thinking of number lines. I've got my 0 here, and I've got my positive numbers, 1, 2, 3, 3, 4. These are my positive numbers. I've got my negative numbers, -1, -2, -3. This is all real. And all of the spaces in between. Well, so if I were to say, oh, hey, x is equal to 2, there it is. It's right there on the number line. Well, what happens if I say x were equal to, say, the square root of -1? I. It's not on the number line. It is literally in another dimension. I could show you that, I could say that we could have our imaginary number line, our imaginary or our complex numbers up here. This is sort of my imaginary numbers. If I were to have, and of course, this I is equal to the square root of -1. Now, this is getting into some slightly more esoteric things. If I've got the square root of -1, yeah, that's I. If I were to take the square root of, say, -4, this would be this would actually be 2i. If I were to take the square root of -9, that would be 3i. And then, then if I were to go out, say I went over here and said, oh, this point right here, this point right here would be -3 plus I. It would be essentially an x and a y. So we can literally think of a complex number as being having both a real, that -3, and an imaginary, the I. Things are getting kind of crowded here on my screen, so I'm going to bring this away for a second. And now that we've got just an idea of what makes, of kind of why it's, why complex is an interesting idea, let's talk about how to simplify something. Let's talk about finding a complex number. So I already said something like, oh, square root of -4 is equal to 2i. And all we're really doing here is whenever you see a negative number under here, I'll say, well, just factor out that square root of -1. Square root of -1 is equal to I. So this is going to be square root of 4 is 2. Square root of -1 is I. Anytime we have a negative number under our radical, we can simplify that down here. If I've got something like square root of -5, no, that's just going to be, well, I still can't simplify the square root of -5, but I could say, oh, that's going to be 5, square root of 5 times the square root of -1. I could technically call this square root of 5i. Because it's a little bit awkward to have anything after a radical, I usually put that I first. I think Alex, if you're using Alex, that it usually will put that square root of 5 first. So you could write it like this, or I think it actually allows you to do square root of 5 and then I. Just make sure that I is not underneath that radical. You want that to end before you put the I there. So this is just a coefficient. So this is how we simplify, or how we kind of come about finding a complex number, or how we go about simplifying something from a radical into this imaginary number notation. Now, there's a couple things that I feel like we really, really, really do need to talk about when we're going into complex numbers. And one of those is simplifying a power of I. And there's a couple different ways of doing this. Let's talk about powers of I. And this is where things get a little bit weird. Remember, I is defined as the square root of -1. So what happens if I were to multiply both sides by I? Well, I would have I squared, but what happens when I square a square root? It just leaves me with, just takes away the square root. It's the opposite. So the square root of -1 times the square root of -1 is going to be -1. This is what makes this so weird. This is the special property of complex numbers. I can square them and they could be positive or they could be negative. Well, I could take the square root of I and I've got a -1. If I were to just multiply through by another I again, I cubed, this is going to be -I. And this one's going to take a little bit of thinking for a second. If I were to multiply by I one more time, I would have, and I'll just put this out here, you'd end up with, if we think about this, this would be negative I squared. Well, I already know that I squared is equal to negative 1. Well, negative 1 is just a positive 1. So I to the 4th power is 1. So I think you might be able to see what's going to happen here. Anytime we multiply by I, it's going to always resolve to either I or some positive or some positive or negative version of 1. Or so I've got, so essentially what I have here is, notice that I've just got I is equal to I squared is, I squared is negative 1. I cubed is negative I to the 4th is equal to 1. And then this process is going to repeat. So if I were to continue on with this, I would say, oh, that's going to be I to the 5th would be the same thing as I to the 6th, oh, negative 1. I to the 7th, that would be negative I to the 8th, this would be 1 again. And that pattern is just going to repeat. One way I could think about this is, remember where I was talking about our real number line and we had our imaginary? Here's our 1. Here's our I. Here's our negative 1. Here's our negative I to I squared to I cubed, I to the 4th, and then so on. It's every time I multiply by I, it's just a rotation. Here's my real, here's my imaginary. This gets, and I think you can understand why for a lot of folks, dealing with imaginary numbers, it can get weird. Let me show you the trick on resolving your powers of I. Here's what I do. Pun not intended. So what I'll do is I divide the power by 4. And what we're going to do is we're going to look at the remainder. If it's 1, then of course we've got an I. If it's 2, we've got negative 1. If it's 3, we've got negative I. And of course, if it's 4, I'd have a remainder of 0. So if it's 0, then it's just 1. So I could say things like, oh, let's take a look at I to the 15th. Okay, 15, I'm going to divide that by 4. 4 goes into 15, it looks like 3 times. There's 12, got 3 left over. So this is 3 with a remainder of 3. So this is going to be the same thing as negative I. Let's do it again. Let's say I've got I to the 33rd. Oh, 33, I'm going to divide that by 4. That'll go in there 8 times. There's 32. I've got a remainder of 1, which means that, I've just got, essentially what I'm doing here is I'm saying, oh, this is, well, actually, this is going to be, my remainder is 1, means I'm got an I. Essentially what we're doing here, when I'm doing this piece, is I'm basically saying, oh, I know that every 4 powers of I is equal to 1. So essentially what I'm doing when we do this process is we're saying, okay, what's happening here? I to the 33rd, this is equal to I to the 4th times 8, that's I to the 32nd, and then times an I. So this is 1 to the 8th power, and 1 is 1 times 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 1 is just 1. So this is just 1 times I. That's all that we're really doing here. Whew. Alrighty. So this is some of our basics on, this is some of our basics on our complex numbers. Alrighty.